Hello everybody. So it's me. I went back to my classroom to get a couple more of these done, so hopefully I won't be, clogging up my house too much with all of the video making stuff. So
Mom,
tell
them that I think my daughter's
Oh, my daughter wants me to tell you that I hope she doesn't make any noise because she's here. Anyways, so today we're going to look at graphs. I'm sorry for it taking me a little bit longer to get this one out. Yesterday was kind of a long day with catching up with gradebook and stuff like that. So we're going to look at graphs of these log functions, and before we actually do that, first we're going to remember what a graph of an exponential looks like. So if I look at y equals 2 to the x, then I'm going to make the graph of this real quick. I'm not even going to do anything fancy with it. I'm going to plug in -2, -1, 0, 1, 2, and then 3, just so I can get a good shape for it. -2, remember that's a negative exponent, so it's going to be a positive 1/4. It flips it upside down and squares it. This is going to be a positive 1/2, 1, 2, 4, and then 8. So graphing that real quick, I'm going to put it on graph paper. Alex, can you hand me one of those rulers over there, please? Quickly, quickly, quickly. She's here, so she might as well be helpful. Okay, thank you. So I'm just going to plot this real quick so we can remember how it works. And so if I'm at -2, I'm at 1/4, and then I'm at 1/2, 1, 2, 4, and then 8. Okay, so I know 4 doesn't come before 8. It's because it's a different kind of counting way, okay? Don't worry about it right now. So this here is our exponential function. And if we remember the shape of it, it goes up and it has this nice little asymptote. It's not going to cross there. Now remember that the way that we defined these logarithmic functions is based off of the inverse of the exponential. So I could actually take this, and if I want to find the inverse of it, right, I would switch my x and y. So I'd have that x is equal to 2 to the y power. And then when we solve this out, we actually can rewrite it as y is equal to, right, exponent is equal to log of my base, and then that number there. Can we stop, please? You're making lots of noise, hon. So if I want to look at the inverse of this function, I'm going to see if I can make a table for it, plug some points in, see what I can come up with for this one here, now that I've got a log function. These ones work a little bit differently. If we think back to when we were doing inverses by hand and we had just a set of points, if I was doing inverses, I would just flip my x's and y's around, right? If this was 1 point, then the inverse would have a 1/4 and a -2. Well, the same thing happens here. If I plug in 1/4 into x, I should get out a -2, right? And if I plug it in here just to see if it works, I've got a -2 is equal to log base 2 of what number, right? If I flip this around, 2 to -2 power gives me 1/4. So it does work. The easiest way to think about these is to list powers of my base here and then say what those exponents are. So I'm literally just flipping these around. Oh, 8 and then 3. Okay, so on this side is where I list my powers of my base. And then on this side, this is what those exponents are. So I'm going to go ahead, I'm going to graph it actually on the same graph so that we can kind of see what that relationship is and see what the shape of this logarithmic function looks like. So let me scoot this over here so I can see my graph and my table at the same time. There we go. So I'm going to be, my x is 1/4, and then I'm down here at -2. My x is 1/2, I'm up here at -1. X is 1, y is 0. X is 2, y is 1. X is 4, y is 2. Then 5, 6, 7, 8, and then I'm up here at 3. So now that I've got this graph on here, we can kind of see the shape of it. you'll notice that it really is the inverse. If I graph this line, y equals x, we noticed this in the last video, that those inverse functions, when we graphed them, that they were symmetrical about that line y equals x. It's like a reflection in order to undo it. What? It just says the word red on it, honey. Okay? I'm sorry. We're distracted today. So, graphing this log function, it's really just flipping around my x's and y's with my exponential. So this one right here is y equals log base 2 of x. Changing the base with a log function is going to make it go out farther, right? Just like changing the base of an exponential makes it gets taller faster. So we're going to go ahead and look at another one, but we're going to try to graph it without first looking at the exponential function that it's related to. So let's look at another example. Thank you. Y-O-U is how you spell you. Sorry. So let's go ahead and let's look at y equals log base, we'll go base 5 of x. Okay? So for this one, as I'm plugging in my x's and my y's, trying to figure out what they are, remember on this side, I'm going to list powers of my base. Just listing out powers of my base. So my base is 5. I'm going to start with 1 over 25, and then 1/5, right? And the powers that give me these numbers are 5 to the negative 2 power gives me a negative, or 1/25. 5 to the negative 1 gives me 1/5. 5 to the 0 power gives me 1, right? 5 to the 1 power gives me 5. And then 5 to the 2 power gives me 25. Okay, so graphing this one, I'm not going to graph most of it because I'm probably not going to be able to get it on my paper. Let me see what I can do. Okay. Now these ones have a vertical asymptote. You'll notice that they get closer and closer to this right here. When x is 1/25, it's at negative 2. When x is 1/5, it's right here at 1, and then here. And when x is at 5, so 2, 3, 4, 5, it's at 1, right? And then 25, let me see if I can get all the way out there. 1, 2, 3, 4, 5. So there's 10, 15, 20, and then, I lost count. 10, 15, 20, and then 25, it's up here at 2. So you'll notice that that higher base really, really flattened this out a lot. It does not rise as quickly. And then, whoops, went up a little too fast there. Gets really, really flat. Okay? Let's look at one where we've got a fractional base, because you might see something like that. Let's say log to the 1/3 x. Right, so now we're looking at powers of 1/3. Another way, rather than listing your powers, it might help if you just list, and remember these sides are your exponents, right? You could list your y's out first. So I'm going to have an exponent of a negative 2, negative 1, 0, 1, 2, and then once I figure out what 1/3 to the negative 2 power is, right, that's going to flip it, so it's going to become a positive 9. This is going to become a positive 3. This is just a 1 still, and then a 1/3, and then a 1/9. Right? That's another way that we can quickly make that table. So let me go ahead and get this graph there. Graphs of logs, they're not something that's incredibly difficult to do. They're something that can just be a little bit new though, because it's not something that you've really looked at many times before. And then 6, and then there's 9. Right. The best thing to do is to make that table so that you can figure out your shape. And remember, you can either list powers of your whatever your base is, right? Starting with negative powers and then working your way up, or you can just list your exponent here and then just plug them in. Either way works. So hopefully that's enough to get you finished up on this. My plan at this point is to come in tomorrow without my kids on Saturday and just get all of the videos made for next week. Hopefully that will be enough to get us going. If you have any problems with Classroom or anything like that, let me know. I am going to post later today kind of like a weekly check-in form so that you can let me know how things are going, if you need help, what it is that you're struggling with, and what else I could do differently. So I hope everything's going great. Miss you guys. Bye.